So, welcome to all of you for this particular module, and here today we will concentrate on two different equipment. One is function generator, which is right over here, and another are oscilloscopes, which are two on which I have my hand, oscilloscopes. All right. But before we move to oscilloscopes, let us first understand what is the function generator and what is the role of function generator. All right. So, function generator, again it is in my hand. Now, we can zoom in. So, we can see clearly function generator is used to create several different signals. All right. Signals in the sense that when you talk about AC signal, it is generally sine wave. But what if I want to get square wave? What if I want to get triangular wave? How can I get this square wave, triangle waves? I can use the function generator. This function generator is from Tektronix. Again, it does not matter from which company you are buying, right? Right now, because we are not worried about the performance. Of course, we should worry about performance, but the module is not to make you understand what is the performance, what is accuracy, what is the resolution. The module is to understand that what is function generator and how we can use it. All right. So, I will again request my teaching assistant Sitaram, who is with me for last two modules also. So, he will help us to understand. When I ask him to press power button, he will press it. So, it is easy for me to talk and easy for you to understand the function generator. All right. So, can we it is already connected to 230 volts. So, can we start the function generator please? So, this is the power button. All right. So, we are connecting the power button and you will see the display. It is always a marketing strategy. So, it always starts from the company function generators and that is fine. Now, what we see is extremely important. All right. So, focus. First thing that we see is sine wave. Can you please show where is sine wave? Yes, this is sine wave. All right. Now, if I want to convert this sine wave, or if I want to apply a square wave instead of sine wave, then what is there? A square wave. See, wave converted to square, right, where your duty cycle is one term that we will see later, on and off time is different. So, how you can say it is a square wave or not, and that is a different topic, but right now we can see the wave is squared. Okay. Next one, which is ramp. If I want to see a ramp, then you see this is a ramp signal, right. If I want to see the pulse, then I can see the pulse, right. If I want to see arbitrary signal, I can press arbitrary button. If I want to see noise, then I can press noise. You see noise, excellent. So, this is the you can apply different waveforms, right. You can apply sine wave or square wave or ramp or pulse or arbitrary signal or noise to a circuit using this function generator, right. Now, what you see on the screen. So, if you just zoom out little bit. Yes. So, I want to show you the channels here, channels are there. Can you see show channel? So, Sitaram, can you please press channel 1? So, right now it is channel 1. Now, can you press another one more time? This is channel 2, right. So, there are two channels. If you see channel 1, channel 2, right, and these are both channels together. So, either you can apply signal through channel 1, or you can apply signal through channel 2, or you can apply signal through both channels simultaneously, right. So, here we can see now we are again pressing it, that means we can go back to channel 1 when we switch off the mode. Now, when you see channel 1, you will also see on the display channel 1. So, it is easy for you to understand, you see the display channel 1. Okay. Now, there are several things that are on the function generator. One is on off button at the channel 1, on off button at channel 2. You see on off is there channel 1 and on off at channel 2, right. So, depending on what channel you want to use, you can use the particular probe. Now, you can change the frequency. Here right now it is 1 kilohertz frequency. You can change the frequency with this push for manual trigger, right. So, there is a knob, you can change the knob, and you will be able to see the change in the frequency. The frequency is how much? Is 1 kilohertz, 2 kilohertz, and so on and so forth, you can change it. So, you can also see that with changing in frequency you will also be able to see the change in time. So, again if you can change the frequency please, you see you have to concentrate on this particular the y axis where it is showing 33.33 333.33 microseconds. If I increase the frequency, can you increase the frequency please? See, again changed, increase it, again change, increase it. So, it is changing, that means you at this point will not be able to see the change in the sine wave that it is increasing the frequency, but if you keep that time constant, then you will be able to see the change in the sine wave. So, we can also change the value using the buttons given. So, we can directly say that I want to use 800 alright, let us say 800 watts megahertz millihertz, 800 millihertz, right. So, 800 millihertz I can directly press 800 and I can get it. If I want to have 1 kilohertz, then I will have 1 and then 3 times 0 or we can directly use kilohertz option also. So, we can just press and we can have kilohertz option. So, there are several options on the side of this screen which are white color buttons, right. So, each of those options are used to change the signal. Let us see the first one, which is the frequency and period. So, when we press the first button, first is your frequency and another one is your period. So, you want to change your period, you can change the value again using the manual trigger knob, and same way if you want to change the frequency, again press the white button and you are back to the frequency mode, again you can change the frequency. Excellent. Now, we go to the second one. So, second knob is a start phase. What is a, so we have seen in inverting amplifier, we have seen in non inverting amplifier, we have seen in oscillators that what is the input phase, what is the output phase, what is the start phase, is it 0 degree, it is 90 degree, it is 180 degree. You can change the phase of the signal by changing the by giving any value that you want to give. So, suppose we are changing the phase, you can see that there is a change in the sine wave, the phase of the signal, and right now it is 15 degree, 16 degree, and you can see the change. Anyway, the next one would be the next white button please, can you, and if you want to reset it back to 0, suppose you want to reset it back to 0, then you can just write 0 0 and you can again press enter and it goes to 0 degree. It is very easy to operate, that is what I am showing it to you. It is very easy, do not worry if system looks very complicated, actually it just looks complicated, the operation is really simple, right. So, if you have all of you use laptop, all of you use internet, if you really see how laptop operates or how what are the circuits within the laptop or how the internet is comes into existence and how the signals are sent, how you can send an email, it is extremely complicated, super complicated, but do you worry? No, because you can easily use internet, you can easily use laptop, this is how it is. It is extremely complicated machine, but what you are using, you are just operating it. So, do not worry when you look at something which is complex, the operation is really simple. Alright. Now, next button which is a white button, now we have seen this is a frequency here, and you can again change it to high level or low level, you can change it to amplitude, amplitude can be whatever voltage peak to peak, right now it is 1 volt peak to peak, you can change it to another see 3 volts, 4 volts, and when you see when he is changing, you can also see the signal on the y axis, if you see minus 2 volt to 3 volts, that means total is 5 volts. So, this is how you can see the change in the amplitude. If you want to change the amplitude, you can easily change using the manual trigger. Next one please. So, next white button, you can see you have, if you want to create an offset, you can create an offset by again changing the manual trigger or by using the display key or the other push buttons. Alright. So, if you see again the offset, you can clearly change the offset. So, now the instead of earlier it was minus 2 volts to 3 volts peak to peak voltage, what is here now 0 to 5 volts, you see it is 5 volts only, but now it is from 0 to 5 volts. So, we can change the offset. Alright, what is the next one please? Yeah, you can change the to whether it is a high level or you can change it to low level. Again if you want to change it, you can see now the it is from 3 volts to 5 volts. So, only 2 volts peak to peak. Okay, can you please go to the next knob, white, that is it, right. So, okay. So, we have this functions in the function generator, but now the main point is how we know that this is the signal appearing, or how we can measure the signal. Now, right now we can see on the screen there is a sine wave. If we change it square wave, we can see change in signal to square wave, but if you want to measure it, then you have to use another equipment, alright. So, first thing is you understand the function generator, very good. Now, how to use this function generator and how to see the display on some other equipment. So, for that we have to connect this function generator to the another equipment called oscilloscope. So, for connecting this function generator to oscilloscope, you need some connectors, isn't it. So, for connecting the oscilloscope and function generator, we are using connector called yeah, it is with in my hand here, right, and we can use this connectors. We can use this connector and we can connect it to the oscilloscope and one side to the frequency generator, right, and we can measure the frequency, we can see the change in voltage, we can see the change in signal by connecting both the things together, alright. So, this is your BNC connector, is called BNC connector, it is also called probe. In general, if you do not understand what is BNC connector, just say multimeter probe or frequency generator probe, oscilloscope probe, right, but if you know the terms, it is better, right. If you know the terms, it is better. If you forget the terms, let us say probe, alright. So, we have to connect our function generator to the oscilloscope. Now, there are two oscilloscopes, one is this one which you may have seen in most of the places, right. A lot of places, lot of universities, lot of institutes, they still use this oscilloscope which is your CRO, alright, or cathode ray oscilloscope, cathode ray oscilloscope. This is your digital oscilloscope, right, it is also called DSO, DSO. This is again from Tektronix, this is the older version and I used personally, like when I was in my undergrad or when I was doing my post graduation or even when I was doing my PhD, I used this oscilloscope. So do not worry about the kind of oscilloscope, but the advantage here is if you can just zoom, yeah, that is good, that is good. You can keep it like this. You see the width here, right, and now let me show you the width of this particular oscilloscope. Oh man, you see, so big, right. Why it is so big, why is so bulky, right. The reason is because we are using CRT, it is called cathode ray tube within this oscilloscope. This itself makes it bulky, there is a creation of vacuum. So, I do not know how many of you have opened the oscilloscope, if you are not open, do not open it, but in case if you somebody are someone of you who are already curious may have opened the oscilloscope, never open a thing in the laboratory, first of all, that is not your property, that is the property of the institute. If you are in government college, it is the property of the not only institute but also of government, right. So, do not ever destroy any component because you are curious. If you are too curious and if you know how to operate the component, how to open the component, how to open the equipment, do it at home in a safe place. First understand the safety parameters, understand what are the things within the oscilloscopes, how you can open it and then only open it. I am not recommending at all that you should open the oscilloscope. What I am trying to put here is that if you open it, then you will see a CRT, and as it names CRT is cathode ray tube, you may also seen TV. So, TV bulkier TVs were there, right, earlier they all were having CRT, Now, there is a vacuum. So, if I put a pin inside the vacuum, what will happen? The air will rush into this particular tube, and that is why there is a blast. Suddenly you see there is a blast. Blast is because the vacuum is gone and air is there within. So, that is why it creates a blast, but anyway we are not interested in blasting anything, we are interested in understanding the oscilloscope. So, cathode oscilloscope here, digital oscilloscopes here, right. Now, let us see that if you want to connect this specific function generator to the digital oscilloscope, how it will operate, alright, and then we will compare both the oscilloscopes. This is the if you know this this many items or this many equipment, it is enough for you to run lot of experiments, to test lot of circuits, alright. So, once you know function generator, once you know DC power supply, once you know multimeter, once you know oscilloscope, once you know variable AC, that is more than enough for you to start working on the experiment part, alright. So, now again I will ask Sitaram to please connect the function generator to the oscilloscope. Can you please do that? Alright, can we please zoom in? Yeah. So, what he is doing? He is connecting the probe, right, to the channel 1. This is channel 1, right, and then he has to connect the oscilloscope. He has to start the oscilloscope. So, I will explain you the function of oscilloscope probably in the next module or in the same module, let us see. But first let us understand how you can connect the function generator to the oscilloscope. So, again this oscilloscope, digital oscilloscope is from Tektronix. There is a provision, if you really see, there is a provision for connecting the USB at the bottom. Can you please show it? At the bottom you can see there is a provision for connecting it to the USB. That means that you can save the signal, you can save your data onto your USB drive, alright. So, like we have all used oscilloscope, right, there is a x axis, there is a y axis, and then there are multiple channels, right, channel 1, channel 2, you can change the signal, you will see that things. Right now let us see that what kind of waveform we can see in the oscilloscope when we connect. Can you please zoom in into his hand, so we can see. So, you see the probe has this long things, two long things, right, two long things, and then he is connecting these two probes, and the shorter version, shorter one he has connected to the shorter one, right. So, the shorter goes with shorter one, longer goes with longer one. When you make the connection, now let us see how it looks on your system here, please. Yeah. So, you can see the square wave, right, you can see the square wave. Now, you can you please move it down. So, there is a function for positioning, right, one is vertical positioning, one is horizontal positioning. So, by vertical positioning he is moving the vertical position. So, you can see vertical, horizontal. Can you please show it? You can always see, but see this is horizontal. When you move the horizontal, the waveform will move in the horizontal axis. When you move in vertical and is a vertical axis. Now, you see for horizontal, for both the channel it is same, only one horizontal position, right. For the vertical there are two different things, one is channel 1, one is channel 2. Right now we have connected to channel 1. So, for easier thing they have also colored it yellow and blue. So, yellow is channel 1, blue is channel 2, excellent. Now, if we change the signal in the function generator, let us see the change in signal. Can you please zoom into function generator? Yes. So, now if I have from the square wave to sine wave, you can see there is a sine wave, right, and he is changing the frequency is about 66.66 hertz, right. So, can you increase the frequency please? Alright. So, now it is 1 kilohertz, right. So, you can see there is a 1 kilohertz frequency. Again you can change the knob. So, when you change the knob, what you are able to see is you are able to see the 1 kilohertz frequency. Again you can widen it by increasing the time. So, or by decreasing the. So, there is a change in the frequency, and the same frequency you can see the change in the oscilloscope, excellent. Now, can you change it to square wave please? Okay, can you change the frequency please? Can you make it a ramp? Yeah, right. So, ramp you can change the sine wave, you can change the square wave, does not matter. So, arbitrary signal you can have, if pulses you have. So, now whatever is showing here on the function generator, you can also see similar thing on the oscilloscope. So, this is how the oscilloscopes are used. Now, we can also stop the signal by run and stop button is there, and here I think run and stop button is here, that is not one, yeah. So, you see you have now captured the signal. This capturing of signal you can save using your USB drive, your USB port, right. So, now we can connect it to the function generator, you can connect your oscilloscope and then you can save the data in the USB drive. Now, let us see that what is the difference between the oscilloscopes that we see here. One is your CRT based or CRO and another one is your digital oscilloscope, all right. So, both the oscilloscopes, let us see what is the difference. Now, can you first zoom in to the digital oscilloscope, which is DSO? Yes, okay. So, let us go one by one. Can you please stop the run and stop? All right, I have done it, all right. Now, you see there are two channels like we have discussed, right. Channel 1 yellow color, channel 2 blue color, right. Then this channel 1 and channel 2 are used for changing the vertical position. So, right now it is connected to channel 1, right. So, can you please change the vertical position? Excellent. You are looking at the y axis, look at the y axis, it is changing, right. Okay, excellent. Can you change the horizontal position please? Horizontal position, very good. See, so you can change the horizontal, you can change the vertical positions, okay, this is nice. Now, similarly for channel 2, all right. Then we have similarly for channel 2, but right now channel 2 has no signal. So, probably we cannot see, but to first start the oscilloscope, first to understand the oscilloscope, you should connect the oscilloscope to the for the compensation, probe compensation. When you start using the oscilloscope, first thing that you have to do is you have to compensate the probe. That means, when you have the probe, you connect the probe to the oscilloscope, you will connect it to the probe compensation knob. It is right here, you can see he has connected to the probe compensation knob, the another one to the ground, and then he is doing the auto set. So, auto set button is there. Can you please show again auto set? Auto set, right. So, you press this and the probe compensation is done. After you compensate your probe, then and then only start using your oscilloscope, all right. It is a good practice to always do a probe compensation, all right. Now, let us go to the function of the oscilloscope. So, now we have the vertical, we have seen the horizontal. Now, let us see the math function. Suppose I want to understand the math function, which is C, M is the math function, right. So, what is this mathematics function? Is it operation, is it a multiplication or addition, or it is a subtraction. So, I want to do a multiplication, for example. So, if I want to do a multiplication, then I have to use this operation, and then I can see. So, I have to apply two different voltages. Right now only one voltage is given, right, one signal is given. If there are two signals, I can use two signals to multiply and I can get that function. Similarly, I can do addition, similarly I can do the subtraction, right. Similarly, I can do addition, I can do the subtraction, all right. So, let us see the white knobs there are there. The top knob, the not that one, this one, yeah. So, this one is used for saving the data, save, right, is for saving the data. Can you please use the next knob? All right. This is the operation, like I said, it is an operation, because now right now it is in mathematical mode. So, it can be used for operation. Next one please. Source, channel 1 or channel 2. Position, right, what is the position? Can you want to right now it is 0 division. So, you can change the position, you see. Next one please. Vertical scale, yes, and again you can change the vertical scale using the vertical scale knob, all right. The knob is just to change the vary the signal, okay, vary the signal, all right. can you use FFT? So, if you want to do Fourier transform, you can use FFT signal and you can do Fourier transform. Similarly, if you have a reference voltage and you want to check the signal with respect to some reference signal, then you can use a reference terminal. Here there is a reference RF, REF, yes. So, that is a button for REF, alright. So, these are several buttons on the oscilloscope, alright. Now, other than that we have cursor, right, on the top we have cursor, right, and then we can write do you want it on or you want it off, is it amplitude or time. So, let us say if you want to connect to amplitude. So, if I am pressing amplitude, I will know see the top signal at the amplitude, alright. One line or cursor is at the top of the waveform, another one should be at the bottom. So, if I want to have another cursor, see cursor 2 you can have at the bottom. Now, you know you can measure the voltage, what is the voltage at cursor 2, what is the voltage at cursor 1, right. So, you can see cursor 1, cursor 2, there is a voltage, you can have the difference, you can measure the difference, this is the use of your cursor, right. You can also do the source, you see channel 1 or channel 2, you can change the mathematical function, FFT, reference function, reference A, reference B. So, lot of options are there when you get a digital oscilloscope. This is a 70 megahertz oscilloscope, you can see on the top the 70 megahertz, alright. Now, other than that save and recall is the same function that you can save the signal and you can recall it later. Default setup is whatever the setup is given by the manufacturer, default setup we can use a default function. Also when you compare this digital oscilloscope with the CRO. So, if we compare both the things, let us say now this is your CRO oscilloscope, right, or CRO means cathode ray oscilloscope. In this you can see the similar functions, but in a more crude way, alright. So, let us see what are the functions. So, first is the intensity and focus, right, because in that we are using in digital oscilloscope either LCD or LED. Here we are using the cathode ray tube. So, here we have to change the intensity, we have to change the focus. So, can we please show the change in intensity? You see, by changing the intensity you will be able to see the change, you see intensity of the signal. Focus, if you change the knob, focusing knob, you can focus the signal. Now, it is not focused, you have to focus a certain point, so focus is there, okay. Then we have a position, you see vertical, horizontal. First let us use the vertical. So, vertical position you can move the signal, horizontal next one, yeah, horizontal you can move the signal in a horizontal x axis, right. So, now you have two positions in vertical, right, first position is for the channel 1, second position is for channel 2. So, there is channel 2, there is channel 1. Now, we can change the volts per division. So, let us connect another probe to this oscilloscope. Here also we can do the testing of the probe. So, we are now connecting the probe, as you see the probe is connected, okay. Now, we have to test the probe. So, there is a probe adjust, yes, you can just connect it to there, another one would be at ground, okay, and then alright. So, anyway this is how you can connect the probe and test the probe, alright. So, do not worry about this one, it is just to show that this also oscilloscope also has the oscilloscope also has the function for testing the probe, alright. So, the point that I was making is, now this oscilloscope has several functions which this oscilloscope also has it, but there are few things in this oscilloscope which this one does not have. That is, one thing is you can easily see the signal, you can see very clear compared to here. Second, you can save the data, here you cannot save the data, right. Third, this is portable, easy, lightweight, this is not lightweight, right. If you want to just compare quickly, okay. But the final point is that oscilloscopes are used to measure the signal and we can change the signal, and we can see the change in the signal by measuring the time or by measuring the amplitude. You can change the peak to peak voltage, you can apply different filters to it, you can do math function, you can here you cannot do. Here you cannot do, right, but here you can do. Of course, you can perform several functions using both the oscilloscope, and it is not necessary that you should learn both the oscilloscopes. If you have this oscilloscopes, fine. If you do not have and you have this one, better, right, does not matter whether you use this one or this one. The point is, if you want to use function generator and you want to measure the signal, you can use oscilloscope as an equipment, alright. So, what we have seen until now, let us quickly recall, right. In the last 3 modules, if I correctly recall, including this one, is we have started with the discrete components, then we have seen the breadboard, right, then we have seen the how to connect the components to the breadboard, then we have seen multimeter, we have connected multimeter to several components, and then we have measured the properties like resistance, the capacitance, frequency, not by connected to components, but by frequency from the variable AC or variac. We have measured the voltage, AC voltage, we have measured the DC voltage, then we have measured the we have understood the DC power supply, right. One was old version, one was new version. In a newer version there was plus minus 15 volts, you can change the voltage, you can change the current. I told you that if you do not know, always keep the current on maximum, probe on maximum. Then you have positive voltage, you have ground, and then we have seen the function generator, which is right over here, and then what is the role of function generator, what kind of signals it can generate, how it can be used, and finally we have also seen the oscilloscopes. Oscilloscopes are 2 types, one is digital oscilloscope, one is the CRO. CRO is based on CRT, this is on LCD or LED, this has multiple functions, fewer better version than this one, but still both the oscilloscopes are used in the laboratory, and it does not matter what oscilloscopes you have, the idea is you should be able to operate the oscilloscopes, alright. So, in the following lectures series, we will see experiments and several parameters that we have already learned in the previous classes, whether it is a operational amplifier, you have to use operational amplifier as an inverting amplifier, or it is a non-inverting amplifier, or we talk operational amplifier as a filter, or we talk operational amplifier as an oscillator, or we have to use the instrumentation amplifier, and lot of other experiments, but the point was that until and unless you are able to know that what are the equipments that we have to use with the circuit, it is useless to start working on experiments, working on the circuits. I can tell you a lot of things about analog circuits, but what is the use, how you can apply it, what kind of equipment you require for measuring the signal, what kind of equipment you require to apply the bias voltage, how can you use multimeter, right, what are the functions within the multimeter. This all things may look extremely basic, but I am sure that learning every time again and again, refreshing the things will help you at some point, right. That is why I am trying to keep lot of things which are basic, at the same time we will see lot of things which are really advanced, right. For example, how you can fabricate indicator circuit, like I said, it is very difficult to understand what is within the IC, right. I took your first lecture and I told you what is within the IC, but if I ask you how you can fabricate the IC, I am sure now because of the lectures that you have been looking at, you are able to understand how MOSFET is fabricated, but if before, if I just ask you that whether you can fabricate a MOSFET, do you know what is the process flow, then probably I am sure that a lot of people would not be able to answer it. But the point is not only to learn theory, but to use the practical knowledge, whatever we learn in theory, apply it in some form, and let us see in few lectures from after this particular module how we are going to use the operational amplifiers and MOSFETs from the experiment point of view, alright. So, I hope now you are clear with this components, with this equipment, and like I said that you don't have to use equipment from this set of companies, does not matter, right. There is a point of accuracy, there is a point of resolution which comes into play when you get a equipment from different companies. So, that is a data sheet that you have to understand how to operate the equipment is already given in the data sheet, but I hope that with this particular set of modules you are now able to, or you are more comfortable in understanding what are these equipments, alright. So, I will see you in the next class, and let us see what experiments we can perform. There are several experiments that I want you to learn, and we will perform the experiments and we will see how we can measure the parameters. So, I look forward to see you in the next class, right. Have a nice day.